We are going to a card trick. This is something that if we were in person, I'd go around, let kids pick cards, and if they did what I got the 2 aces, they'd win. But unfortunately, nothing is the way it's this year. All right, so my example says, suppose I have 5 cards to choose. You guys can see my cards. 2 of them are aces. You can see and we're going to select 2 cards, and we want to find the probability that we draw 2 aces. Like I said, I would go, we would actually get to pick cards if we were in or not. So we define as A, first card selected is an ace. Event B, second card selected is an ace. So the probability of A, so what's the probability right now that if I pick a card, I'm going to get an ace? Either in the chat or let me know. What's the probability we get?
Out of 5.
So it's 2 out of 5 because we have 2 out of 5 cards total. And it tells us that we're picking a card at a time. So then I put my ace back. What's the probability that I pick an ace? Still 2 out of 5. Thanks, Emma. And Jake, I saw your answer in the chat. Thank you. So 2 out of 5. Now, say that I do the same thing, but this time I'm going replace it. So that means I don't get the card back. So the probability of A, what's the probability of an ace for the first card? What's the probability of an ace? It's not a trick question. Thanks. 2 out of 5. Still 2 out of 5. All right. To my ace. What's the probability I pick now?
1
out of 4. So this leads us into our definition for today. The probability that one event happens given other event be known to have happened is a conditional probability. Suppose we know that event A has happened, which was the example, we actually got an ace. Then the probability that event B happens, given that A has happened, is denoted by P of B given A. And given literally just a straight up and down line. So that's what we're going to be focusing on today, is the probability an event happens given another event has happened. So we're going to continue with cards, because cards I think are a little tangible to uncover what our rule is, conditional probability. So we're going to keep working with the example of Jackson that we worked with last time. So we're going to shuffle our standard deck of playing, and we're going to deal 1 card at a time. So we have 2 events. Event A means we get a jack, and then event R is a red card. So make a 2-way table to give our space. We have this 2-way table before, but it's a good reminder to make a 2-way table. To make like a big tic-tac-toe So we have event J, or the complement J complement, meaning it's not a jack. And total, our element is a red card, red complement, and then the total. And remember that bottom right is your grand total spot. And we know that there are how many in a standing deck? 52, thanks. So and then we're gonna in. So how many jacks deck of cards?
4.
4, thank you. Which means how many cards are jacks? Thanks, Jake. How many cards do we have total?
26.
Thank you. Means we have how many non-red cards?
26.
Thank you, sir. Of our jacks are red.
2. Never mind. Wait, yeah.
I hope 2. It sounds like 10 to me, but
2, I'm sorry.
no, that's okay. It just, you guys know through Zoom, sometimes a little harder to understand things, and it had a t sound, like 10. I'm going to go with 2. So we have red jacks, which means that 2 of our are not red. And of 26 red cards, 2 of them are jacks, which means that 24 are not jacks. Same with the non-red, non-jack cards, 24 of them. So like I said, we've done this two-way table before. It's a good little reminder on what we're going to have to do and we haven't done before. So we want to find the probability that the card we pick is jack and it is red. That probability. We've also answered that question before in a different lesson. Probability that our card is a jack and it Thanks, Taylor. 2 out of 52. So probability that it's jack and red is 2 out of 52. There are 2 red jacks total, and we have 52 cards we're picking from. What's the probability that it's a jack?
Four out of 52.
Thank you, Emma. 4 out of 50. So now we're going to find the probability that the card is red, and we know that it's a jack. So probability that is red, and I'm going to write it out in words because that's the first time we've seen it. Okay, given it's a jack. I was going to write words, and then I thought that really is in words. Given it's jack. So what is the probability that it's a red card given it's any kind of venture a prediction on that probability?
Would it still be 2 over 50?
It would not be 252. You were close though, Emma.
4 over 52?
Almost. It's a combination of the
say
How'd you get 1/2, Taylor?
because half of the jacks are and half of them are black.
Yep. So, take 1/2, which is correct. And we said out of the jacks, because we card is a jack, so 4 jacks, 2 of them are red. So 2 over 4, 1/2. Now, like I told you, that comes from a combination of these two. Because if we know that it's a jack, and we want to find out that it's red, we're going to take the probability that it's a jack and red, divided by the probability that it is a jack. Change color. It doesn't all blend in. So 2 over 52 divided by 4 over 52. And then a little side, just as a reminder, you have a fraction divided by fraction. Remember, you multiply by the reciprocal of the one you're dividing by, so the top stays the same, but I'm going to multiply by the reciprocal. So I multiply by 52, 4, and then our 52's cross cancel, and we get 2 over 4. Now, on this example, pretty simple to see that we have 2 jacks out of 4 total jacks. It was a jack. But that's not always, so we do need to know how to get using the formula. And that leads us to the 4th probability rule. Is given that event A has occurred, the probability event B will occur. So probability of B given A is the probability of A and B divided by the probability of A. So notice the given is what we're dividing by. So now we're going to use the formula for some examples. It's okay if I flip the page? I'm going to take silence. Yes. All right. We're going to look at the Titanic. I was obsessed with the Titanic. I don't know why. And it wasn't because of the movie. Reading about it before the movie came out. The movie came out when I was in like 6th grade. Man, that makes me feel old. So in 1912, the luxury liner Titanic, its first voyage across the Atlantic, struck an iceberg. Some passengers got off the in lifeboats. Sorry. Boats. But many died. The two-way table gives information about adult passengers who lived and by class of travel. Suppose we choose an adult passenger at random. We're going to answer A and B. So A, given that the person selected was in first class, what's the probability that he survived? And then B says if the person survived, what's the probability she was a class passenger? So just as a reminder, before we get into this, we're going to use our conditional probability rule that says the probability of B given A comes from the probability of A B divided by probability of A. The other thing that we need to do before we get into this, if you look at the table, yes, it gives us class of travel for second and third class, they survived or died, but we don't have any totals. And I suppose there's total ones that you need to use, but I personally like to have my totals done first. I don't actually use the wrong pieces of information. So I'm going to add a total and a total row. Total. So total for first class, 197 plus 120. So we have 315. Second class, 94 and 167 is 261. Oops. Third class, 151 plus 476 gives us 627. Survived, 196 plus 94 plus 151. 442. Died. 2 plus 167, 476, 765. And then if I didn't make any mistakes, my row total, my column total should match total. So 82, 765, 1207, 319, 261 plus 627, 1207. The person was in first class. Given that they're in first class, we want to find the ability that he or she survived. So we need to find the probability that the passenger selected survived given they were in class. And use our rule up here, so the probability they survived and were in first class divided by the probability they were in first class. So survived and in class is 197 out of 1207. The probability they're in first class is 319 out of 1207. I just showed that we have a fraction by a fraction, we end up multiplying by reciprocal, which is conveniently to eliminate our denominators since they match. And we have 187 out of 3. And this time I'm going to as a decimal. Sorry, I feel like I have to sneeze again. With cards, because it's out of 52, I don't know why it is fraction, but here, oops, 97, I'm going to turn it into a decimal. So the probability that the person survived, they were first passenger, is approximately 61.8%. Any questions before we move on? Okay. All right, this time we're person survived is our given condition. We want to figure out what's the probability that they were a third-class passenger. So probability third-class passenger, and they survived. We're going to find the probability that they were in third class and survived. And we're going to divide by the probability that they survived. So third and survived is 151 out of 1207. Probability they survived 442 out of 1207. Our denominators conveniently would cancel if we were to show the multiplying radical. And we get 151 out of 442. And again, we're going to get an approximate decimal. 151 divided by 42. So the probability they were in class, given they survived, 0.342 or 34.2. Question before we move on.
Does it always put about before the decimals?
Rounding, yes. Something like on the previous where you get 2 out of 4. There we are. 2 out of 4 and an exact decimal 0.5. You don't have to put the about, but if you're rounding your decimal, yeah, you should put about. Any other questions before we move on to breakfast? All right. So, the following table describes 595 students who responded to a school survey about eating breakfast. Suppose we selected random category events B, eats breakfast regularly, and event is male. So we're going to find the probability they eat breakfast regularly given it's a male student. And the new part to this is we're going to explain. We're going to write a sentence stating what it means, and then we're going to find the probability that the student is male given they eat breakfast regularly, and then write a sentence that explains our answer. Probability, oh, by the way, this table has total rows and columns. Sometimes they don't, sometimes they do. So I try to make my notes. So probability they eat regularly given they're male. We want to find a probability that they eat regularly and they're male. Divide by the probability that they're a So, breakfast and male. Breakfast male is 190 out of 595. Probability they're male is 3 to out of 595. The denominator, both my friends match, so they would cancel each out, and I get 90 over 20. Which is 0.59. So then the new explain what it means. And really, that's what, when you explain what it means, you're just in this mathematical sentence. I'm going to put it into words. So, probability that they eat breakfast regularly is about 0.94. Make it sound a little better grammatically if we talk about the given part first. So by given the student is male, I would expect that breakfast regularly about 9.4% of the time. And like I said before, English is not my strong suit, so you guys may need to make it sound better grammatically. Given the student, I'm going off the edge. Student is male. We would expect they eat breakfast regularly. .9% of the time. Any questions so far before I move? Alrighty. So they just switched, and so this time what's the probability the student is male? They eat breakfast regularly. So given they eat breakfast, probability that they're male and they eat breakfast divided by, oh no, my pen died. So probability they're male eat breakfast is the same as the probability they eat breakfast and they're male. I don't really say that it, sorry, the word that comes to mind is community. It doesn't matter which order, whether you say and male or male and breakfast, it's the same probabilities. So that top fraction is the same here, so it's 190 out of 595. The bottom is what changes, because this time we want the probability they eat breakfast regularly is 300 out of 595. Our denominators out, and we get 190 over 300, which is approximately 0.63333. All right, anybody want to give it a shot on interpreting our answer, putting it into words? Nobody? Okay.
When the student eats breakfast regularly, you would expect to fail 63.3% of the time.
Perfect. Thank you. So, given the student eats breakfast regularly, we would expect they are male 63.3% of the time. Questions before we all right, last one. Given the information in a table, so we need to either make a two-way table or a Venn diagram so that we figure out probability. So Matt Gore, a recent census at a major university revealed that 40% of its students used Mac computers, the rest mainly PCs. At the time of this, 67% of the school's students were undergraduate, were graduate students. And 23% of the respondents were graduates who said that they use PCs as their computers. Suppose we select a student at random among those who were part of the census and the student mainly uses a PC. Find the probability that this person is a graduate student, and then obviously show work. So we are, I lost my highlight, bummer. All right, so it tells us that the student mainly uses PC, and we want to find the probability that this person is a graduate student. So this is our given condition. So we want to find the probability that they're a graduate given use a PC. So we are going to take the information given to us. We're going to make a two-way Venn diagram. That way you can see both of them. Hopefully you can figure out which one clicks to you so that we can answer this question. So down here, we're going to do our table on the left. Working in percents, so what should our grand total be?
Either 1 or 100.
So either 1 if you change percents to decimals, or 100. I is 100 because I don't like to possibly make a mistake. And if I leave them as percents, like I didn't make a mistake. That doesn't mean I could still make a mistake. Our two events that we're interested in are graduate and using a PC. So I'm going to put graduate across and I'm going to use, I suppose I should define that. E means they're a graduate. And G complement. And then P will be that they use a PC. PC user. So we have P and P complement. And then we're going to take the information they gave us and fill it in. So 30% mainly max. So that would be P complement. How's it going?
Good, how are you?
I'm doing pretty good. So we would have 40% of student education uses a Mac, so doesn't use PC, P complement. It then tells us that 67% of the students were undergraduates. So G is graduate students. P complement could be not a graduate student or an undergraduate. And we have 67 there. And then it tells us the rest graduate students. 23% were graduate students who said they used PCs as their primary computer. 23% are graduate students and use a PC. So graduate PC would be 23%. Then we're going to fill in our missing pieces. So PC user percent were not a PC, so that means 60% use PCs. 67% undergraduate, which means that what? 33% would be graduates. 23 plus 10 would give us 33. 10 plus 30 would give us 40. 23 plus 37 give us 60. Sorry, double checking. The 3 sevens threw me off. Then we have our two-way table. Now we actually answer the question. I do want to draw our Venn diagram. So remember, when you draw a Venn diagram, you need it in a box that shows the entire sample space. So everything should add to 1. And we have our two events that were included in, which was their graduate student and their PC user, which means that this overlap here is graduate and PC users. Now remember, anytime you do Venn diagrams, you start with the overlap. So that would be the 3% who are graduate and use PCs. So we're going to 0.23. Now here, I don't know, I always use decimals in Venn diagrams. Over here, if it's percents, I leave them as whole. Oh, that's weird. And then we have to do a little bit of mental math. So it tells us 40% use Mac computers. Have Mac is one of our events or circles. We have PC, which is the opposite of Mac in this situation. So 40% use Mac means 60% use PCs. And we have 23 of 60. We would have 0.623 over here, which is 0.7. Then we're told 60% or graduates, but we want to know what are graduates. So we would take 100 minus 67, which is 33, but we already have 23% of them. So that leaves 0.10% in just the G. And then Venn diagrams. Here is G complement and P complement. So we would take 0.1 plus 0.23, which is 0.33, 0.37, which would be 70. So that means we have P out in the G complement and P complement space. So notice that whether you use a table or a Venn diagram, we have the same force: 23, 3, 37.37, 10.1, point. So we get the same information. It's up to you which one makes more sense and you are more comfortable creating so that you can answer the question. So now we're actually going to go back in the probability the student is a graduate given they use a PC. On top, we want the probability they're a graduate and use a PC. On the bottom, we want to divide by the probability they use it. So, graduate and C, here is 23 out of 100, or in our Venn diagram, 2, 3. Probability they're a C user, if we look at the two-way test, that would be 60 out of 100. In our Venn diagram, that would be lap and the stuff just in the P. 0.23 plus 0.37 is 0.6. .23 divided by 0.6, about 0.333333. And then just get in the habit of explaining what our answers are. So, given the student is a PC, we would expect them to be a graduate student. Currently 38.3% of the Do you guys have any questions for me?
I'm a little bit confused because the formula on the back shows that it says like probability that you do probability of A and B over probability of A, and on this one we did that, except for we did the probability of P, which is the second one, which I was confused why that switched.
So the conditional probability formula is B given A, comes from the probability of A and B divided by the probability of A. The bottom is always your given. So we were given they used a PC, so we divided by the probability that they use a PC. And like here, probability they were male given they ate breakfast. We did male and breakfast divided by male. Always divided by our given.
Okay.
Did I clarify, Taylor?
Yeah, kind of. I was just kind of confused by the 8.
Yeah, it's honestly, Taylor, that is where I see the most mistakes with this formula. The bottom is always your given condition. Unfortunately, I don't have like a mnemonic device or something helpful to like help you remember that, but the bottom's just what we're given. Any other questions?